Hi, welcome to my video on find the intersection of two parabolas. The previous videos we found the intersection of a parabola and a line, algebraically and graphically. So we're going to find two parabolas, intersection of two parabolas. To find the intersection algebraically of this system of equations, notice this one is a quadratic x squared, this one is a quadratic x squared, highest degree of a term, and it's in we call standard form. And we're going to solve, so we'll let x squared minus 2x minus 8 equal negative x squared minus 8x, because they're both equal to y, so they're equal to each other by transitive property or substitution. So x squared plus x squared minus 2x plus 8x minus 8 equals 0. So we moved all terms to the right side and made it equal to 0. We simplify, we get x squared, and x squared is 2x squared plus 6x minus 8 equals 0. So now we have a quadratic that I see 2 as a, so I got 2 as a common factor, so I can I can do two things, and I'll show you both of them. I can factor out the 2 and get x squared plus 3x minus 4 equals 0. Or I could divide all the terms by 2. So 2x squared divided by 2 is x squared. 6x divided by 2 is 3x. Negative 8 divided by 2 is negative 4. 0 divided by 2 is 0. So either way, you'll still end up with the same equation, but in this case I'll have 2, and this is a quadratic that's factorable, so it's an x squared, which is x and x. The product of 4 to give you 3 must be 4 and 1. The product is negative 4, the sum is 3. So a plus 4 and minus 1 will multiply to give you negative 4, and add these two and you get 3. So that means that the 2 cannot be equal to 0. Nope. So x plus 4 equals 0, or x minus 1 equals 0. So x is negative 4, or x is 1. And if we have x equals x equals negative 4, then I'll sub that back into, and I'll pick, both of them are quadratic, so I'm going to sub it back into either, well, this one got 3 terms. So I'm going to sub it into, let's call this one number 1 and this one number 2. So x equals negative 4. I'm going to sub x equals negative 4 into number 1. Y equals x squared minus 2x minus 8. So x is a negative 4. X is a negative 4, so I'm subbing negative 4 in place of x. I'll square first to give me 16. Then I have to multiply to give me 16. And 32 minus 8 is 24. So that means we have x is negative 4 and y is 24. That's one point of intersection. Now I'm going to deal with subbing. I'm going to sub x equals 1 into number 1. Y equals x squared minus 2x minus 8. And I'm subbing 1 in the place of x. And 1 squared is 1. We multiply. It's negative 2 minus 8. So we get negative 9. So the point is 1, negative 9. So there's 2 points of intersection, and both of them. So if you take either one of these points, if you sub this point into this equation, it will be true. If you sub it into this equation, it will be true. So, and if you take this point and sub it into both equations, they'll be true. So there's 2 solutions. So the 2 parabolas intersect. And again, notice that this parabola is opening up, like number 1, the parabola is opening up. And this parabola is opening down, so they're crisscrossing like this. And not the exact locations now. I'm just giving you one is up and one is down, and they're both intersecting, but they're not at these exact points, as you can see. Okay, let's continue. Find the intersection algebraically. Again, we have two parabolas. They're y equals ax squared plus bx plus c, and the same with this one, standard form. And so we let 3x squared plus 2x minus 1 equals x squared minus x plus 1. Because they're both equal to y, we'll let the expressions in terms of x equal each other. So 3x squared minus x squared plus 2x plus x minus 1 equals 0. So I move all terms to the left side in descending order, and if I move them to the left side crossover, it changes sign. Positive becomes a negative, negative becomes a positive, and the plus 1 becomes a minus 1. So that gives me 2x squared plus 3x minus 2 equals 0. So I have a quadratic that's equal to 0, so I can do this two ways. I can do it by factoring, or I can do it by quadratic formula. But let's try factoring just for a bit of review. Notice this is a 2. 2 is not a GCF, so I can't remove it. So the product is 2 times negative 2, which is negative 4, and the sum is 3. So the factors of 4 are 1 times 4 and 2 times 2. So the factors that give me a 3 would be 1 and 4. So 1 times 4. But the product is negative and the sum is positive, so it has to be positive 1, negative 4. Multiply, negative 4. Whoops. How about negative 1, positive 4? Again, I check myself. Multiply, negative 4. Add, 3. So I take those two numbers and go negative 1x plus 4x minus 2 equals 0. So now I'm doing it by what we call grouping. So we put a negative 1, make a negative 1x, a 4, make it 4x. Notice you add these two terms and you get the middle term here. And now we do grouping. Underline these. So we take the x, which is common, out of the first two. So 2x squared divided by x is 2x. Negative x divided by x is negative 1. And I see a plus, whatever that sign is, whatever this sign is, you put it here. And 2 is a GCF, so take the 2 out. So 4x divided by 2 is 2x. Negative 2 divided by 2 is negative 1. And 2x minus 1 is common. Binomial GCF, what's left is x and a plus 2. And each of those factors are equal to 0. And so 2x equals 1, and we divide by 2, x is 1/2. And plus 2 becomes a minus 2. Now we have the parabolas again intersecting at two different values of x, so we have two ordered pairs. So let's work on the 1/2. So let's sub x equals 1/2 into. And again we have two equations. So this is number 1 and this is number 2. We want to label them. I'm going to sub them into number 2. So y equals x squared minus x plus 1 is number 2. So x is 1/2. So I'll sub 1/2 in. Notice when I sub it in, I put it in brackets. 1/2 squared is 1/2 times 1/2, which is 1/4, minus 1/2 plus 1. Common denominator for these fractions is 4, so that's 1. And 4 is the denominator, so 2 into 4 goes 2. 2 times 1 is 2, so 2 over 4 is 1/2. And 1 is the same. Common denominator is 4, so 4 over 4 gives me 1. Common denominator is 4, so I'll add, and I'll get 1 subtract 2, negative 1 plus 4 is 3. So that's the point 1/2, 3/4. And we're going to sub x equals negative 2 into, again we'll go into number 2. Again, you can put this value into either one of these equations. I elected to go into 2. So negative 2 minus negative 2. So notice the x is in, put a bracket on negative 2, and I put a bracket around the negative 2 here. So I square first to get a 4, then I multiply, where negative over negative is a positive. And so when I add 4, 2, and 1, I get a 7. So that's the ordered pair of negative 2 and 7. Again, these two parabolas intersect at 2 points. And if you had to do this one graphically, you would not be able to graphically to get this point, because when you do graphically, the points have to be integers in order for you to pick them up. But if the points of intersection are not integers, like rational numbers or fractions, or if they're roots, like root 5 or 1 plus root 3, you wouldn't be able to pick it up. So graphically is only good when it hits at integers. And let's continue. We have another one to do. Find the intersection algebraically. Again, we have two parabolas, but each of these forms are vertex form. So what we do, we still let two sides equal. Because they're both equal to y, then they're equal to each other. So now, best to do is to simplify the square. Let's square each of these out first. We just want to remove the square. So x plus 2 squared is right there. So we do FOIL, x squared plus 2x plus 2x plus 4. First, outside, inside, last. And I'll do the FOIL on this one. X times x, x squared, x times negative 3, negative 3x, negative 3 times x, negative 3x, negative 3 times negative 3 is a plus 9. And we simplify all those terms. When you simplify each side, you have less to move. And when we do, we have moved all the terms to the left side, and when we do, we change, and we get 7, minus plus 7, gotta be careful, minus 7. So this x squared moved over to become a minus, this plus minus 6x moved over to become a plus, and this 7 moved over to become a minus 7. They cancel out, and they cancel out, so 10x equals 0. Divide by 10, x equals 0. So 10 times what number is 0 is 0. So x is 0, so we're going to sub x equals 0 into. So which equation do we want to go into? It makes no difference. This is equation 1 and this is equation 2. I'm going to sub them into equation 1. So y equals x plus 2 squared plus 3. X is 0, so we sub 0 in the place of x. We work out the inside of the brackets first, which is a 2. Then we square to get a 4. And we add 4 and 3 is 7. So the point of intersection 0, 7. So these two parabolas are both intersecting at 1 point. 1 point. If you looked at the graph of them, then you probably see that point. Or if you have a graphing calculator and you graph it with a graphing calculator, you would see the point. But now, when you do algebraically, it always works out. Graphically, you got to be careful. The point, again, when you do graphically, it has to be point, has to be integers in order to spot it. Other than that, you won't find it. Find the intersection algebraically and graphically. So this time I'm going to do both of these algebraically and graphically to illustrate. So we have two equations. This is the general form, and this is the vertex form. So we'll let x squared plus 1 equal negative. And what I do is that I square this first, so this is x minus 2, x minus 2. The left side is okay, and I do the negative on this. So notice I'm squaring this, so I'll multiply these two first by FOIL. X times x, x squared. X times negative 2, negative 2x. Negative 2 times x, negative 2x. Negative 2 times negative 2 is 4. And I always simplify that product before I do anything else. That's done. Now I'll do the negative 1 times this expression. So negative 1 times x squared, negative x squared, negative 1 times 4x. Negative 4x is positive. 4x. Negative 1 times 4 is negative 4 minus 1. And I'll simplify again this side before I transpose. So I have an x squared plus x squared, and I have a plus 1 minus 4 plus 5 equals 0. So I have a 2x squared, and this becomes 4, that becomes 2, so plus 2 equals 0. So I have a quadratic and I'm going to have to solve, so it's easy. So take the 2x squared equals negative 2, divide by 2, x squared equals negative 1. Square root of x squared is plus or minus the square root of negative 1. X equals plus or minus I. And I have an imaginary number. That means that there's no intersection. These two parabolas do not intersect. So let's look at the graph of each of these. The graph of y equals x squared plus 1. Y equals x squared plus 0x plus 1. Notice the x is missing, so it's 0. So let's look at the vertex of this parabola. So x is equal to negative b over 2a. So that's the negative of the 0 over a is 1, b is 0, c is 1. 2 times 1, so that's 0 over 2, which is 0. So the x-coordinate of the vertex is 0. So I'm going to sub 0 into the equation, and I get 0 plus 1 is 1. So the vertex is 0, 1. And it's opening upward. So let's see, the vertex is x is 0, y is 1. Because the parabola is positive, then it's opening upwards. So what you can do, if you wish, you can do a little table, put the vertex in the middle of 1, 0, 1, and then do a 1. So 1, put a 1 in. I get 1 squared is 1 plus 1 is 2. So that means if I put a negative 1 in, negative 1 squared, negative 1 is 1 plus 1 is 2. So when I have x is 1, y is 2. When I have x is negative 1, y is 2. So the parabola is opening up like this. Notice the parabola is positive because that's a is plus 1 or plus. And notice no matter what values of x you put in, plus or minus, when you square it is always plus. So the values of y in this parabola, the values of y are always greater than 1 because x squared is always positive when you plug in real numbers. And let's look at the other parabola. What about looking at y equals negative x plus 2 squared minus 1? The vertex of this parabola is the opposite of negative 2, which is 2, plus, opposite of negative 2 is a 2. So when x is 2, this becomes 0, and y is negative 1. So the vertex is 2, negative 1, and it opens downward. Notice there's a negative here, so it's opening down. So let's just see. If the vertex is 2, negative 1, x is 2, y is negative 1 right there. There's your vertex. And because it's negative, it's opening down. So this parabola has this vertex here opening downward because of the negative. Then this parabola has to do this. And besides, if I let x equals 0, which means I'm finding the y-intercept. So if I let x equals 0 in my equation, negative 2 squared minus 1 is the negative of 4 minus 1. I get a negative 5. So that means my when x is 0, y is negative 5. So there it is right there. So my parabola really comes downward, but to be more accurate, if I put that y-intercept in, my parabola will do this to be more accurate. I just drew it downward, and I knew when I drew it downward they wouldn't intersect. So graphically there's no intersection also, because one parabola is here with this vertex opening up, and this parabola here got this vertex opening down, so they'll never intersect. So that's explaining it algebraically, where I get an I number, and when they don't intersect, you'll get an imaginary number underneath your root if you did the quadratic formula. I didn't do the quadratic formula, I solved it simpler. So that's explaining the intersection of two parabolas. And if you like my video, click the like button, the subscribe button, notification bell. Visit my website www.mathfullyexplained.com to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye bye.